our mini lecture on right triangle trigonometry, and we'll call this part 1. So the first thing we'll do is introduce you to a right triangle. So a right triangle is a special type of triangle with a right angle being that 90-degree angle. So that little half box or square that you see, that represents 90 degrees for that angle. So a 90-degree angle is a right angle. So thus, a triangle with a 90-degree angle is known as a right triangle. It's a right triangle. So for a right triangle, there are some special characteristics. So the first thing I'll do, I'll label this angle right here with the Greek letter theta. And if we look at all the sides in the way of looking at it through theta, let's say we're standing right here behind theta and we're looking out this direction. So this side right over here is known as the opposite side. Sometimes it's just shortened OPP for opposite. This side down here, right at the bottom or next to us, is known as the adjacent side. Sometimes they shorten that as ADJ. And then this side right here, the side that's always opposite of the 90-degree angle, that's the longest side of any right triangle, always. And that's known as the hypotenuse. All right, and sometimes they just use HYP for hypotenuse. So we have theta, and looking at through theta, we have opposite, we have adjacent, and hypotenuse. From those, we create the first three basic trig functions. So the sine of theta. The sine of theta is known as the opposite over the hypotenuse. The next one is the cosine of theta. The cosine of theta is known as the adjacent side over the hypotenuse. And when we're talking about the sides are usually going to be some number of value, like maybe 3 or 10 or 15, right? And maybe it's a measurement in the real world in centimeters or meters or something like that. All right, and then the last one of the first basic three trig ratios will be tangent. So the tan of theta is going to be opposite over adjacent. So we have the sine of theta, opposite of hypotenuse, cosine of theta, adjacent over hypotenuse, and tangent of theta, opposite over adjacent. So you should probably commit these to memory while understanding how the ratios work when applying them to a right triangle. Okay, so if we move to an example, let's say we have something that looks like this. It's another right triangle. Maybe they'll orient it in different ways, but we know it's a right triangle, right? Because of that box right there in the corner. So we know that angle P is 90 degrees. We don't know how much angle R is, or we don't know the measure of angle Q either. However, they do tell us that this side is 14 and this side is 50. All right, so the first thing we may want to do is, maybe to help us answer some questions, is figure out this side right there. To me, when dealing with a right triangle, if they're giving us this side, if we look at the right triangle, they're giving us this side right here where the 14 is. Thinking back to the Pythagorean theorem, oops, sorry about that. That side is known as a leg, right? So that's a leg right there. That's a leg right there. And then that's a hypotenuse, right? We just talked about the hypotenuse. So you have two legs in the hypotenuse. We'll call this side A, side B, and they're both interchangeable, AB or BA, whatever. The only side that is not interchangeable is the longest side, the hypotenuse, and that's usually known as side C. So if you recall, the Pythagorean theorem was c squared equals a squared plus b squared, right? That's the Pythagorean theorem, and that's only for right triangles. If given two sides, you can figure out any other side. So it looks like we're given the hypotenuse, which is 50, and then we square it. And we're given this 14, which is one of the legs. So we take that and square it. And then this will be b, the other leg. So we'll say b squared. We don't know what that is. So we go ahead and crunch the numbers. 50 squared is about 2,500. 14 squared, that's 196, right? 196. And then plus b squared. Well, just do a little bit of algebra. Subtract 196 from both sides. Subtract 196 from 2,500, you get 2,304. Subtract 196 from 196, you get nothing, which is what you want because you want b squared by itself. And now to get b, you have to use that square root property that you learned before in algebra. The square root of 2,304 is 48. So side B is going to be 48, right? So I can go ahead and replace that B with 48. And again, if they're using units, it'll just be whatever units that they have in the problem. So we have a right triangle with sides, legs 14 and 48, and a hypotenuse of 50. So let's go ahead and answer some questions about the trig ratios. So let's say they're saying to us, find the sine of Q. Maybe they'll say find the sine of R or something like that. Maybe they'll say find the cosine of Q. Maybe they'll say let's find the cosine of R. And then the tangent of Q. And then the tangent of R. Let's clean that up a little bit. The tangent of R, we're saying. All right, so the sine of Q, the sine, remember, is opposite over hypotenuse. Opposite over hypotenuse. So that means we're looking out from Q, and the opposite is the 14, the hypotenuse is 50, the longest side. So it's 14 over 50. Of course, you can reduce that, right? That reduces 2 goes into 14 7 times, 2 goes into 50 25 times. And then you just do the same things for the other ones, right? The sine of R. Well, you're going to go to R, look at it from R's perspective, point of view, and the sine. Sine is opposite. The opposite is B, side B, which is 48, over the hypotenuse. Sine is opposite over hypotenuse, so 48 over 50. So that'll be 48 over 50. And of course, you can reduce that. So that'll be 24 over 25. And then what you should do is get a little practice and go ahead and answer the next four. Pause the video and answer the next four. And remember that cosine is not the same as sine. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Tangent doesn't even include the hypotenuse in that ratio, in those ratios. So take a pause and then come back. All right, and then you should have gotten 48 over 50 for this, which is 24 over 25. For Q, you should have gotten 14 over 48, which reduces to 7 over 24. the cosine of r, 14 over 50, which we could have reduced to 7 over 25. And the tangent of r is 48 over 14, which we reduced to 24 over 7. All right, and let's move on to an actual problem where we need to go ahead and solve for one of the sides of a right triangle. So for instance, let's say our right triangle looks like this. We have a right triangle, we know because of that box. One of the legs is 17, the other leg is x, and we know that this side right here is the hypotenuse. We don't know what it is because there's nothing given there. But we do know that this is 48 degrees. Looking at a problem like this, the first thing you would take a look at is that the angle they give you is 48. So all of the trig ratios will be looking from that viewpoint, right? So whether it's the sine, remember, is opposite over hypotenuse. Whether it's the cosine of whatever theta is, cosine is adjacent over hypotenuse, or whether it's tangent over tangent of theta. So I should write theta for each one, and that's going to be opposite over adjacent. So looking at this, we don't know the hypotenuse, right? And we don't need to know it either. But the things that we are given, kind of given, but not really. We're asked to solve for x, but we see what side is that? Well, the side opposite that is 48 degrees, this is the opposite. And the 17, we're given that to the 48 degrees. This is an adjacent side. So we're given opposite and adjacent, right? Opposite and adjacent. So that would tell me to use the tangent. I surely can't use the other two because we don't know the hypotenuse. We don't know the hypotenuse. You need the hypotenuse for the other two, and we don't know it. So I would only use opposite over adjacent. So then I would go and say, okay, let's find the tangent of 48 degrees because it's equal to the opposite, which is x, over the adjacent, which is 17. So then the tangent of 48 degrees, you have to just punch that in your calculator. Make sure your graphing calculator is in degrees. The mode is in degrees and not radians. So then you get 1.110612515 equals x over 17. Well, for something like this, you can just put that over 1. You have a proportion, and then you can just cross multiply. So 1.110612515 times the 17 equals 1 times x, which is just going to be x. So x is going to be, if we multiply these two, and then let's say I just want to round it to the nearest 10th place. This would be 18.9. So we've just solved for x, 18.9. This next example, we're given the angle of 67 degrees. So everything is from that perspective. So it looks like we're looking at x and 29. So x, this side is the opposite side. So we're given the opposite side of 67 degrees, right? And then we're not given what's underneath that bottom right there. We don't know that. That would have been the adjacent side, but we are given that 29. That's the hypotenuse. Remember, the side across from the right angle is always the hypotenuse. So we're given opposite and hypotenuse. So if you look at all the trig functions, sine, cosine, and tangent, sine theta was opposite over hypotenuse. Well, all we need to do is now just plug in theta. Our theta is going to be that 67 degrees. The opposite side is x. We still don't know it, but we're going to know it soon. And the hypotenuse is 29. So then the sine of 67, punching that in your calculator, is 0.9205048535 equals x over 29. Again, you can put this over 1 and then just cross multiply. 0.9205048535 times 29, and then 1 times x. So that means x will just be whatever that product is. So 0.9205048535 times 29. Punch that in your calculator and round it to the nearest 10th. you should get 26.7. All right, so this was the quick and basic introduction to trig ratios.